Greetings and welcome to this 3D Motive comprehensive course on creating a box-pushing puzzle game in the Unity engine. I'm Alan Thorne and I'll be your instructor as we explore how to build a 3D puzzle game every step of the way from start to finish. Throughout this course we'll take an in-depth look at a wide range of Unity features from level design and lighting configuration to inverse kinematics, character animation and also load and save game functionality. In this fifth and final part of the course, we'll engage our scripting-oriented brains for a C# coding extravaganza. Here we'll dig deep into creating a load and save game system that'll let the player save and resume their game between playing sessions. To achieve this, we'll see the player preferences class as well as the monoproject framework for reading from and writing to XML files with the XML serializer. By the end of this part, we'll have achieved a functional box-pushing game and you'll have taken your Unity skills to the next level. So, let's get started. So now we're going to just recap and take a look at just how far we've come in this course, because actually we've come a long way. We've created a box pushing game here where the objective is for the player character to push the boxes onto the destination points, and we've created two levels, Scene 00 and Scene 01. What I have open in front of me here is the first level, Scene 00, and when the player completes this level they'll move to the next one, which is Scene 01. I've gone ahead and created Scene 01 off screen. Let's just maximize the viewport so you can see it better. And we have this level here. The starting point for the boxes are here and the destination points are over here and the player begins here. And in creating this game we've relied on quite a whole wide range of features of Unity really. We've illuminated the environment here, the floors, the walls and the pillars using light mapping, which is static lighting. And then we've gone ahead and created the boxes and the player character and they are illuminated using light probes. We've also created some fiery torch particle systems that are on the wall, and we use that using the shuriken particle system. And also we've got the player character over here which uses skeletal animation as well as inverse kinematics. So we've seen a whole lot in this course, and what I'm going to do now is just to jump back to the first level, Scene 00. And I'm going to start playing this level and I'm going to complete it from start to end, and then I'm going to jump to the next level and complete that from start to end so that you can see how to complete both levels. I'm going to play these levels in a kind of time lapse so you can see in fast motion how I complete these levels so we don't have to wait for too long. And then after doing that I'm going to examine where we go from here. So here I go. I'm going to just press play on the toolbar here. And I'm going to start playback of the game. Actually, I'm going to just stop playback. I'm going to switch to the game tab, maximize the viewport, and press play so we can see it in a kind of full screen view. So I'm going to press play. And, well, let's go. So you've now seen how to complete the game, both levels from start to end, but there's still one big problem and one feature I would like to implement in this game, and that is load and save game functionality. Right now, if the player reaches the second level, or if we add more levels and the player reaches those, then when they terminate the game they don't yet have the ability to jump back to the level they were last playing. And what I want to do now is I want to build in that load and save functionality. Now, because this is a casual puzzle game, it's the kind of thing that the player will be playing on a kind of casual basis, then I want to really just load back and restore the level as the game begins. So when the game starts, we want to check to see if the player had any previous session to restore, and if they do, we will restore that. Now, in creating this functionality, there are two main kinds of data that we will need to save. First, we want to remember which level the player was last on. So, for example, if they reach scene 01 and then they terminate the game, we want to restore that level back to its initial state. That's the first thing that we want to do, so keep track of the level the player reached. But also within that level, the player will have maybe moved boxes or moved the player character. And we also want to save those changes too, so that we can not only restore the level, but we can restore the configuration of that level. So we want to restore the position of the boxes and the position of the player. To achieve this functionality, we're going to be using the Player Preferences class and also XML serialization. We're going to begin doing that in the next video, where we consider the Player Preferences class. So in this video, I want to consider the Player Preferences class, and we're going to be using that to store which level the player was last on. Now, I've jumped over here to a web browser window. If you look at the address bar, you can see I'm at the Unity documentation, playerprefs.html, and I'm looking at the Player Preferences class, and you can see quite a detailed description of that is provided for you in the Unity documentation. Now, the Player Preferences class acts like a database that we can save data to and retrieve data from. It's really useful for storing small pieces of information, for example, the brightness of the screen, the resolution that the game should run at, and whether it should run in windowed mode or full screen mode. So it's really useful for kind of saving the options data that the player may specify. It's not so well suited to storing more detailed data, such as the configuration of complete levels. We'll see how to do that later using XML files, but right now we're going to be using Player Preferences to store the level that the player was last on. Now, this Player Preferences, it works like a database basically. If I scroll down, you can see that we've got a range of functions that we can use. I've got setString, setInt and setFloat, and these allow us to write values, write data to keys in the database. So I can set a string value, set an int and set a float, and we have these other functions, getFloat, getInt, getString, to read values from the database. And this data is stored persistently across game sessions. So if you store it to the computer, it doesn't matter if you exit the game. The next time you run the game, these values will still exist. You may wonder, where does it store this data on the local computer? Well, that depends on the operating system that you're using. If you're using Windows, you can see that it stores the data in the registry, and for other operating systems, it stores them in files in particular places. So you can visit this documentation if you're interested in seeing where exactly the data is stored. I'm going to jump back over to Unity and start using this class to save which level we reach. So I've jumped back into Unity here, and now we're going to get started at using the Player Preferences class to implement level loading functionality. You can see in front of you here that I have scene 00 open, and this is the first level in the game, and it is loaded when the game begins. Now, we have the Game Manager class, and there's an instance of this class in each and every level. So what we can do is we can add a start function to the class, which will query the Player Preferences database to see if the player has ever reached a later level before, and if they have, we can load that level. Otherwise, we leave the player on the current level. So what I'm going to do is I'm just going to open up MonoDevelop here, and here is the Game Manager class loaded in MonoDevelop, GameManager.C#. And right now it doesn't have a start function, so I'm going to be adding one of those. Let's just insert some spaces here. I'm going to type void start to create a start function, and we're going to get started at coding this function now using the Player Preferences class. So the first thing that we want to do is to query the Player Preferences database to see if there's been any level previously loaded. So what I'm going to do here is I'm going to type if and Player Preferences, and you can see here we have Player Prefs dot has key, which will check the database to see if there's an existing key, and I want to check for a key which is going to be called last level. I'm going to be using this key, which I've customized here, called last level. We're going to be using that to store the last level that the player reaches. It's going to be an integer property. So if the Player Preferences database has a key that is named last level, it means that the player has previously played this game and reached some level. We don't yet know which level that is, but we're going to find out. So let's retrieve the last level that the player has reached. So I'm going to type int last level, and we're going to choose player preferences dot get int, and I'm going to be getting the integer for the last level. So here we are. We say last level equals player preferences dot get int last level, which will retrieve a number indicating the last level we reached, and then we want to compare that last level. So I want to say if the last level is greater than the current level, which is application dot loaded level. If it's greater than the current level, then that means the player has previously reached a level beyond the current one. And so we want to load that level. So I'm going to say application.load level. We've seen the load level function before, and we're going to be loading the last level. However, of course, if the player hasn't got the last level key in the player preferences database, or if they haven't reached a later level, then we just want to continue with the current level. And I'm going to set the current level to be the current last level. So we're going to say set int, and we're going to say last level, like so, and it's going to be set to application dot loaded level, like so. And there, in creating those lines, we've created all the functionality that we need to resume playback from a later level. So I'm going to press Ctrl S on the keyboard, and in the next video we're going to be testing out this code and seeing how it works. So in the preceding movie we created level loading functionality using the player preferences class, and you can see that here in the start function for the game manager class. And what I've done off screen is I've gone ahead and completed the first level of the game and reached the second level. So if I just minimize MonoDevelop, you can see that we've got the first level open here. Now if this level loading and saving functionality is working, it should mean that when I press play on the toolbar we reach the second level, and indeed it will do. Let's just press play to test that. And ta-da, you'll see that actually now when I press play, we're on the second level and we're not on the first level. And that's because this is the level that I last reached on a previous game session. So it has indeed stored that data and retrieved it back from the start function in the game manager. So everything is working quite nicely. But of course the problem is when I press play, we always begin back at the second level. What would happen if we wanted to just change the value manually and test out things? For example, what happens if I wanted to press play and go back to the first level during testing? Well, of course, we can easily change this value that's been stored in the player preferences database. On the Windows platform, you have to actually access the system registry to do that. I've just brought up here on the screen my registry editor. This is the registry editor for my system, and I've located the key here that you can see in the registry. It says last level, and it has some letters and numbers after it, but this is the last level value that has been stored for our project. And right now you can see over here in the data section that the value is set to 1 because that is the level that we have reached. I could just double click on this and change this value back to 0 and press OK. Let's just move that out of the way, press play on the toolbar, and now we go back to the very first level. Notice that update there on the key has really made a difference to that data. So I'm just going to press stop again. I can come back into here and change this value back to 1, choose OK, just move this out of the way again, press play on the toolbar, and now we're back to the second level, which was the original data. So that's looking pretty good. We've now got the player preferences class to implement this level loading functionality. What this will do is it will allow the player to reach absolutely any level they like in the game, and every time they resume playback it will load back that level. That's excellent, but of course the main problem that's facing us now is of course the player always begins back at their default location. The boxes are restored at their default location. These positions for the player and the boxes are still not saved. We're not going to be using the player preferences class to do that. Instead, we're going to be relying on XML. So in the previous movie, we created level loading functionality using the player preferences class, but one thing that functionality didn't do is it doesn't allow us to restore the positions of the player and the boxes in the level. It loads the level, but the player and the boxes are always set to their default or starting positions. And what I want to do now is I want to allow the player to resume the level and also to have the position of the player and the boxes restored as well. Now to do that we could use the player preferences class, but I don't think it's appropriate for that, and instead I'm going to be using a persistent file that we're going to save on the computer and load the data back from that file. Now there are different ways we can kind of implement this functionality in games. We could use a binary or proprietary file, and that's the most common method in games because it means that the user, the gamer, can't simply open up the file and edit the data. They can't really understand the data at all or change it, so it prevents them from cheating. but instead we're going to be using an XML file which is human readable, but it really makes debugging easier for the game. It allows us to open up the save game data, have a look at it, inspect it and change it if necessary. At a later point we could convert the data to a binary system. So I'm going to be using XML data to save the game data here, and to do that we're going to be using the Mono framework, which effectively is an open source version of the .NET framework built into Unity, giving us a range of different classes we can use for saving data to the system. Now before I go ahead and do all of this, I want to inspect a sample XML file that I've created for this game, just to show you how exactly we're going to be storing the data. But before I do that, I'm just going to bring up a Windows Explorer, a Firefox window actually, and look at the text editor I'm going to be using to examine the XML. And this is Notepad++. You can download this application on Windows for free by going to notepad++.org, and this text editor gives you a range of different features that makes it very easy to examine and explore XML files. It gives you syntax highlighting and all kinds of other syntax folding as well, as we're going to see. So I'm just going to minimize Firefox here, and I'm going to bring up Notepad++, and we can see here that we've got our XML file, a sample XML file that I'm going to be using for the save game. So let's take a look at this XML file. So the root node in this file is the game data node, which encompasses all the save game data that we're going to be storing. There's a little plus next to that allowing me to expand it, and then as child objects beneath the game data node we have BD and PD. BD refers to box data and PD refers to player data. So under the box data node we're going to be storing the position of all the boxes in the level. So I'm going to click on the plus to expand that, and you can see we've got box data, box data, box data, box data and so on. That's because I've already gone ahead in advance and created the functionality. This is actually a save game for the second level because we have 6 boxes here. So here is the first box, here's the next box, the third box and so on. So if I expand, for example, the first box, you can see that we've got box transform and on destination. On destination is marked as false, meaning that when the game was saved the box was not on its destination. But each of the boxes also has a box transform, which is effectively the position, orientation and scale data for the box. So again I can click plus to expand that, and you can see we have the X, Y, Z positions of the box, the rotation values in Euler angles, that is degrees, and we also have the scale X, Y and Z factors here. So that's the data effectively for a single box, and we have that repeated for all of the other boxes saved from the level. So I'm just going to really close up the box data here. Let's expand the player data, and the only thing that we store for the player is the player transform data, again the X, Y and Z values, the rotation and the scale data. So effectively this is the data that we're going to be storing from a save game, and this is just one complete save game for the second level. It includes all the box data and the player data encompassed in the game data nodes. So that's the basic XML structure that we're going to be used for creating a save game. The question remains as to now how do we code that into our Unity project. We're going to get started at doing that next. So in this video we're going to get started with data serialization in Unity to save the position of the boxes and the player. To get started I'm going to create a new class to do this. So I'm here in the assets script folder in the project panel. To create a new class I'm going to right click and choose create from the menu, and I'm going to choose C# script. And I'm going to name this class Data Manager, like so, and press enter on the keyboard. So now we've created a new Data Manager class, and I'm just going to open up this class in MonoDevelop. So I'm going to double click the Data Manager class. And here we are in MonoDevelop. So we have the beginnings of this class, Data Manager, derived from MonoBehavior. And the first thing I'm going to do is I'm just going to highlight the top section here where we are including various namespaces. We're going to be replacing these, and I've actually copied a number of namespaces to the clipboard. So let's just paste these in here with Control V, and we have a range of different namespaces here. So we have quite a few: Unity Engine, System.Collections, Collections.Generic, XML, XML Serialization and System.io. We're going to be making use of all of these different namespaces. These contain various Mono framework classes, which is an open source .NET implementation built into Unity. This contains a variety of different classes we'll use to effectively serialize our game data to an XML file. So what effectively is data serialization? Well, what it will allow us to do is effectively to take a class, we're going to be using the data manager class, to store all of the save game data, and it will allow us to stream or save a class to a file, and then later on we can load back that file and reconstruct the class just as it was when we saved it. That effectively is serialization in a nutshell. But the big problem with serialization, the thing that we have to take care with, is that not all the different data types can be serialized. Only a limited set of data types can be serialized, and so we need to keep track of the different types that are allowed and that we can serialize, and we can only use those. So we're going to be seeing cases of this later on. So right now I've created this data manager class, and we're going to be really getting started from this point. Now let's move on with the data manager. The first thing I'm going to do is I'm going to remove the mono behavior section here. Let's just put this onto a new line. I'm going to remove the mono behavior section because I'm not deriving from mono behavior. We're creating more or less a base kind of class here. And so that means I'm going to remove the update and the start functions from the class, so we begin from a completely empty class. Now we know, for example, that all the objects, the crates and the player, we're going to want to store the position, orientation and scale of those objects. So the problem with those classes, those objects, is that Unity uses vectors and quaternions to store that data, and that data is not serializable. So we're going to need to create our own class, our own structure to store that data using types that are serializable. So I'm going to do that now. I'm going to type public struct data transform. This is going to be a data structure that's going to keep track of all of the transform data that we're going to be using. So we need to store the X value, we need to store the Y value. This is the position data for the object. We're going to have to store the Z as well. We'll also need to store the rotation of the object. So we're going to be saying float, and I'm going to say rot X like so, public float rot Y. This rotation is going to be stored in Euler angles, that is degrees, so float rot Z. And we also want to store the scale of the object as well. Again, that's going to be scale X, float, public float, scale Y, and finally public float scale Z, like so. So in doing that, I've created these general float values which are serializable and we can use to store the transform data for the object. So I've created a data structure, data transform, and we're going to be using this structure to store the position data for the crates and for the player. So next what I want to do is to effectively add box data and player data. In the preceding movie, we created a data transform structure which stores the position, rotation and scale values for any object in the level, including the boxes and the player. And what I want to do now is I want to extend and add some new class definitions that is going to keep track of the box data and the player data. So to do this, I'm going to be pasting in some code so you don't have to see me typing in every single line. So let me just insert a new line here and press Ctrl V on the keyboard to paste in some new data. So I've created here a new box class which is called box data, and you can see that it relies on the data transform structure we've defined up here to keep track of the position, orientation and scale for any single box. So there will be an instantiation of this box data class for each and every box in the level to keep track of its position. We'll also keep track of whether it's on the destination at the time the game is saved. We've also got player data here, which really just keeps track of a data transform member to record the player position. I've created a separate class for this because of course we may at some later stage want to add additional data if we decide to add extra features to the game. And then finally down here we wrap up these structures together into a game data class, and this is going to be the actual class that we will serialize to an XML file. You may remember when we had a look at the XML file that the game data was the root XML node, and that really is significant. This represents all the game data wrapped up together. So first of all we have a list. We use a list data type to store a list of all the boxes in the level. This list class again is part of the Mono framework, and we can use it to really keep track of a dynamic array. It doesn't matter how many boxes we have in the level, whether it's 1 or whether it's 10. This list structure will keep track of all the boxes in the level. It will be sized exactly to accommodate exactly the number of boxes that we need. So here we have a list structure for all the boxes in the level, and then we have the player data. So really this game data class brings it all together and wraps it all up. Now what I want to do now is I'm going to instantiate a new member to this data manager class. That's an instantiation of this game data that we're going to be serializing to a file. So I'm going to insert a new line under here and type public game data GD equals new game data, which instantiates a new game data class that you can see here, and that's looking pretty good. So we've got game data GD equals new game data. And the last thing that I want to do is scroll up to the top of the class here, the data manager class, and I'm just going to paste in this line here, XML root game data. And what this effectively does is it names the root node in the XML file. So we're going to be naming this XML game data. So what I'm going to do now is I'm just going to press Ctrl S on the keyboard to save all of that information, like so, and just minimize MonoDevelop. Unity goes ahead and compiles that code. Everything so far is fine, but what we don't have a save and load function which we're going to be using to actually save and load the data to and from an XML file. We have our data structures in place to store all of that save game data. The game manager is going to be calling upon a lot of this data here, but we need to implement some functions into the data manager class, such as a load and a save function, which will actually write all of this data to an XML file. We're going to be considering that in the next video. So now let's add load and save functions to our data manager class to save game data. So I'm just going to come over here and put my cursor here and paste in some new code, and then I'll explain what it does. So we have a save and a load function. Let's start with the save function. So with the save function, it accepts a parameter of string file name, which is going to specify a complete path on the system where the data should be saved into an XML file. Now on the first line, we create a new serializer object, which is of the type XML serializer. The XML serializer class is included in the Mono framework and is used to serialize a class to an XML file. We create a new instance of the XML serializer, and we have to tell the serializer which kind of class we want to serialize, and indeed we want to serialize a game data class which we've declared up here. In the next line, we want to say, okay, we're saving this to a file, so we create a new file stream, and we're passing it the file name where the file is to be created, which is the argument put into the function here, and we're creating a new file by using the filemode.create argument. And then in the third line, finally, we use the XML serializer class created here to serialize to our file, which is indicated by a stream. We serialize the instance GD, which is an instance here of the game data class. And then finally, we call the stream.close function to confirm that operation. So in this process here, using this save function, we save all of the game data here in the game data class to an XML file. Now the load function works very similarly. It's really just the same process but in reverse. So we have in XML serializer class, and again we create that here, specifying type game data. We create a new file stream, but notice this time we're not creating a file as we did here with filemode.create. Instead we're calling filemode.open because we are opening an existing file on the hard drive. And then finally we use the serializer class to not serialize as we're doing here, but to deserialize the class. So we're taking that file and we're deserializing it as a type of game data, and the result is being stored in the game data variable, which is here in the data manager class. And then finally we call the stream.close function to confirm that operation, load back that data and close the file on the hard drive. So using the save and the load functions together, we can write data to an XML file and retrieve it back. But of course, this data, the save and load data, in combination with all of these data structures that we've created here, is not enough on its own. We've created the data structures to hold the game data. We've got the game data member here, which contains all of the game data we need to save. We've got the save and the load functions, but on its own, nothing actually populates this game data class. We create it in memory and it's initialized with all of its default values. We still need to take the game data actually in the level, the player and the crates, and we need to put them into this game data object so that we can actually record the state of the level. We're going to be doing that inside the Game Manager class. The Game Manager class is going to be handling this, the dealings with the game data here, and calling upon the save and the load functions to save and load the data respectively. So in the next video we're going to move away from the Data Manager class because this class is now completed. You can find it in the course companion files in the datamanager.c# file. Instead we're going to be moving back to the Game Manager class and implementing the saving functionality there. In the preceding movie we managed to complete the datamanager.c# class to hold all of the game data we're going to be saving to an XML file, but we still need to go back to the Game Manager class and make it interact with the Data Manager so we can actually transfer out the real game data in the level, the player and the crate data, into the structures we've created that can be serialized to a file. So I'm going to switch back now to the Game Manager, and I'm going to be adding two new variables to our Game Manager class. The first one is going to be private data manager dm equals null. That's going to be a reference to the data manager class where we're going to be holding all of our game data. But I also want a reference to the player controller class in the level because I'll need access to the position of the player and the general status of the player. So I'm going to be creating a private variable for the player controller. Let's just spell that correctly, it's case sensitive. So player controller PC equals null. Again, we're going to initialize that to the variable of null. Both of these values I'm going to populate in the awake function here. So the data manager, we're going to be initializing that to a new instance of the data manager class, like so. And the player controller, well, I'm going to be getting the player controller in the level. So I'm going to be saying player controller equals, and we're going to say game object dot find objects of object of type. There's only one player controller in the scene, and we're going to be finding player controller like so. And that function call there will give us the reference to the one and only instance of the player controller in the level. There's only going to be one instance of it because there's only one player. So in this call here we create a new data manager, and in this one we create a new player controller. This will be necessary to get the position of the player so that we can save it to a file. So that's a good beginning. We've initialized these values for the Game Manager, but of course we need to move on. I'm going to be creating a save game function for this Game Manager class now, which will take the data out of the level and put it into the structures we've created here, the serializable class, so that we can save that data. We'll be looking at how to do that next. So now we've added the data manager, the DM variable, to the Game Manager class, as well as the player controller PC variable. And we create or initialize both of those variables down here in the awake function. We create a new data manager and we retrieve a reference to the player controller object so that we can save the position of the player. What I want to do now is to add a save game function to the Game Manager class, and whenever we call this save game function, it will save an instance of the game to an XML file, the status of the current level. So I'm going to scroll down to the bottom of the Game Manager class right here, insert my cursor, and I'm going to paste in some code that I've already copied off screen. So I'm going to press Ctrl V on the keyboard to paste in this code, and you can see the code here is a save game function. And now let's take a look at exactly how this function works. In the first line we have dm.gd.bd.clear. Let's see exactly what's going on here. We've got dm, and we know that that refers to the data manager variable that we've added to the Game Manager class. And the gd variable, if we jump back to the data manager class, you can see that the gd variable is an instance of the game data here. So this refers to the serializable game data structure. So I'm going to jump back to Game Manager. So what this line does is that it effectively clears out the list of boxes in the game data structure. So it says we're initiating a new save operation. There may be previous data left over from previous save operations, but we're not interested in those. What we want to do is to completely clear out the list of boxes, if there is one, and we're going to be adding the boxes in the level to a completely new list. So here we cycle through all the boxes in the level. You can see this for each loop cycles through all crates in the level, and you may remember from a previous part of the course, if I scroll back up here, that we create a private array here of all the crates in the level. So we have a crate array, there's a crate component, and we have an array of all crates in the level. This array is populated further down here in the await function, where we get all the crates in the level using the find objects of type function to retrieve all crates. So I'm going to scroll down here back to the save game function we're working on. We cycle through all the crates in the level, and here is where we populate the transformed data for the box. So we create a new box data. We say for the transform X, Y, and Z, we get the transform position for each of the crates, and also for the rotation. Notice that the rotation is being taken from Euler angles.x and Euler angles.y and z. It's not using the quaternion data directly, it's using the transform.Euler angles component. And here we've got the local scale.x, y, and z, and we also record whether the box is on its destination. And then finally, of course, we return back to the data manager and call the add function to add the box to the list. If I return back to the data manager, you may remember here in the game data structure, we use the list object, which is BD, to create a list of boxes. So in the game manager class, when we call the add function here, we're calling the add member of that list class to add this newly created serializable box data to that list. So we cycle through all the crates in the level, and for each box we create this new serializable data and add that to the box list. And by the end of here, when we complete this loop, all the boxes in the level will have had their data translated into a serializable form in the game data structure ready for saving. But of course the box data is not the only thing that we want to save. We also want to save all of the player data as well. In our case, all we're doing is we're saving the player transform data, and you can see that here by using dm.gd.pd.player_transform, and we're saving out the position, Euler angles, and the local scale for the player character as well. We're loading all of that into the player data for the game data object, and we're saving that to the file. Finally, we actually save the game data. And it's important to see how we're doing this. We're calling on the data manager save function. If I switch back to the data manager save function and I scroll down, you can see we've got the save function that we've coded here previously, and it accepts an argument to a file on the computer, an XML file that we're saving to. I'm going to jump back to the game manager, and you can see how we're piecing together this local save position here. We've got the gamesave.xml file, but notice that we're prefixing it with application.persistentDataPath. Now the actual value of this variable will change depending not only on your operating system but also on your computer. It can change across computers even with the same operating system. But what the application.persistentDataPath does is it keeps a reference to a location, a folder location on your hard drive where Unity knows it can safely store persistent data. So the actual location for this will vary from computer to computer, but you can know that this variable, application.persistentDataPath, always keeps track of a location where we can store persistent data. So in this dm.save function, we're piecing together a path. We're saying this folder plus gamesave.xml file, and so when we run this save game function, it will generate this XML file containing all of our game data. So that's a good way to go ahead and create a save function. I'm going to press Ctrl S on the keyboard to save all of that data, minimize MonoDevelop, and Unity goes ahead and compiles that data. Excellent, we've now completed the save game function. Next up, I'm going to be looking at creating a load game function. Here we'll code a restore game function into the GameManager.C# class, and in many respects this will work like the reverse of the save game function. But there are some significant differences that I want to point out. So I'm just going to bring the cursor in here and press Ctrl V on the keyboard to paste in the relevant code, and here we have the restore game functionality. So here, right now, we've got the restore game function, and the very first thing it does before it restores a game is it uses the system.io file exists function to check to make sure that the relevant XML file storing the saved game data actually exists on the local storage, because it's only if that file exists that we can even restore the game. We can't restore data when there isn't data that exists, so right now we have to check for the existence of the file. And then we call the DM, the data manager.load function, passing the application.persistent path value with the gamesave.xml. And this goes over here to the data manager class, and it calls on the load function that we've seen already, which uses XML serializer to deserialize the XML data into the game data object. So let's switch back to the game manager. This means that after we call dm.load, we know that the game data class, the game data member here, will contain all of the save game data that we need to load back into the level. So the way this works is we cycle through all the boxes in the game data. So we read back from the XML file just exactly how many boxes were saved. We cycle through that number, and then we update the relevant crates in the level to their relevant positions, rotations and scale. Notice here in the position we're creating a new vector. Let me just move over a little bit here. And we're passing in the transform.x, y and z data into a vector3 constructor here. And also here we're creating a new quaternion based on Euler values, that is degree values on the x, y and z axis, and you can see those values passed in here from rot x, rot y and rot z. And the same for local scale, we're creating a new vector3 structure, passing in those values, and we're also updating the is on destination, and we do this for each and every box that has been saved. And then finally we update the player transform. That is, we update the position, rotation and scale of the player. So in calling this function, really, when we call this restore game function, we load back the game data. So that really is the core functionality that we implement into the game manager class relating to the save game and restore game. But there still is some more work to do, and we're going to consider what that is next. Now, of course, I've said before that the application.persistent data path value differs across operating systems and computers, but that whatever it is, it always expresses a folder on the local computer where Unity knows that you can store persistent data. Of course, when you go ahead and save that data to that location, you might want to know where that folder is on your computer, so that when we finally come to save this gamesave.xml file, you can open that up in Notepad++ or any text editor that you choose and examine and edit that data. So how can we know what this value is? Well, there's a really easy way to do that. We can call upon our trusted friend debug.log, and it's really simple to use. So I'm just going to scroll up here to say the start function. Let's say I want to know what the application.persistent data path is. I can simply type debug.log, pass in application persistent data path, press Ctrl S on the keyboard to save those code changes. Let's just minimize MonoDevelop here. I'm going to switch to the console over here, and I'm going to press play on the toolbar, and you'll see here printed in the console here, I've got the full path, and it tells me what it is to the application here. So I've got the full application path. I know what this is now. I can go ahead and pick out the relevant XML data that has been saved. For you, the location will be different, but just be aware that you can use debug.log to print out the application.persistent path. So that's a really easy way how you can find out what that value is and how you can access your save game data. So now it's time to create the remaining functionality for the GameManager.C# class that will let us save and load our games completely. So I'm just going to start by scrolling down in our source file here. I'm in the GameManager.C# class. I'm going to scroll down to the start function that we created before, which you can see here, and here we've created the start function where we use the player preferences class to determine whether the player has previously got a save state session and whether we should load that level back. Now we know that if the player has this last level flag set in the player preferences database, then they will have previously saved their game at some point. And here we actually load the level. But if we enter this code block, we know that, for example, we want to restore the game from the previous session. We want to restore the state of the level. So what I want to do here is I want to call on the restore game function. That will restore the game if there is a game remaining to restore. So I'm not going to press Ctrl S to save those changes. But of course, what about saving the game? Well, for our game, we know that really we want to save it whenever the player terminates the gaming session. So every time they quit the game or exit the game, we'll want to save the game state, because that's the point where playing stops. We want to save it so that at a later time when they play again, they can resume that session automatically. So I'm going to scroll down because I'm going to insert a new function, which is a Unity API event that we can have called whenever the application is terminated. It's a special event known as onApplicationQuit, like so, and you can assign this on any MonoBehavior object to receive a notification when the application terminates. So in this function, I'm going to call save game like so, and press Ctrl S on the keyboard, and that should be everything that we need to do to save and load our games. So let's see this in action. I'm just going to minimize MonoDevelop, and I'm going to get started at saving our game. So now I'm just going to press play on the toolbar. Let's just press play here, and we begin at the second level. We know that we should have done so because the player preferences class stored the last level we reached, which was the second level, but notice that everything now begins at its default starting position, and that's because previously we hadn't coded the XML functionality to save the position of the player and the boxes. And notice that we didn't get any error generated because when this level started, there was no game XML file to restore from. But if you remember, we have that function, the system.fileIO, which checks whether the file exists. Because it didn't find a saved game file to restore, it didn't bother executing any of the restore functionality. But I've loaded the game up here, and what I want to do is to make some changes that are going to be restored. So I'm going to move some of the boxes out of their default positions. Let's just push this box forward onto, let's say, its destination here. Just going to push this box around here onto the destination. I'm also going to move over here and bring this box forward onto its destination, like so. And I'm going to move another box, but not put it onto its destination point. So I'm going to move over here, for example, to this box, and I'm going to push it forwards like so. And I'm going to have the player stand in the corner around about here. And I'm going to press the play button on the toolbar to stop the application. And when I do this, the onApplicationQuit function will be executed in the Game Manager class to save the game state. So I'm just going to press this button to stop playback. And I'm going to bring in a Windows Explorer window. You can see here in this window that it has generated a gamesave.xml file which contains the game's data that we've just saved. So we can confirm that the file is created. I'm just going to bring this Windows Explorer window out of the way and press play on the toolbar again to resume our game. So this time when I press play, we should begin from the second level, and it should restore the box and player positions. So let's press play, and you can see straight away the player is standing in the corner of the room where we left him. This box has been pushed forward by 1, and we should have also 2 boxes on the destination points. And we'll take a look at these over here, and let's walk forwards just a bit more. Yep, and there are the 2 boxes that we pushed onto the destination points. So this has successfully saved the state of the player and the boxes. Actually, if I press the stop button now and I press play button again, you'll see the player is now standing here because it's saved their position. So that's splendid. Let's just bring back the Windows Explorer window, and let's just open this gamesave.xml file in Notepad++ just to confirm that these settings are working and saved as intended. So here in Notepad++, we know that, for example, 2 of our boxes are on the destination. So let's just expand the box data tab and take a look at the different boxes. So that one's not on the destination, and again we can say that one is on the destination, the second one, and the third box, that's not, the fourth box, that's not, the fifth box, that's not, and the sixth box, that is. So we know the second and the sixth box are on the destinations, and they're the only 2. So these 2 boxes are on their destinations, and indeed this is how this is reflected in the scene. So we know that it's saving out this data fine, it's saving out all the transformation and position data in the XML. Of course, we could actually come in and start editing this data in the text file, and everything would work great because we would save this and it would be updated in the game. This gives us a great way of debugging and seeing the data that we're saving, being able to change it if we need to. And so everything's looking pretty good. We're now able to save and restore our game in 2 senses. We can load back levels we've resumed previously. We can also load back all of the data that we've saved in the level, the position of the player and the crates. Things are looking good. I want to now talk about a potential bug that arises simply because of our load and save game functionality and how we can go about correcting that. You'll see here in the player controller C# class that I've coded in the handle input function. Let's just scroll up a little bit. We've got the handle input coroutine, and here I'm responding to the R key on the keyboard. I'm saying that when we press the R key on the keyboard, I want to restart the game, and it calls on the game manager.restart level function to do that. And all that function does is use the application.loadLevel API function to simply restart the same level. You can take a look at that if you like. It's in the game manager.c# file. I'm just going to minimize MonoDevelop. Let's go ahead and play our game and see what bug occurs. Well, here we are running around in our second level. I'm going to start moving some boxes around. I'm going to push this box forwards into the corner. Now when I do this, I make the game unwinnable. So at this point, I'm going to want to restart the level. So I press the R key on the keyboard and it simply restores the level. And you can see this box has been pushed back to its default starting position. Now I'm going to push the box forward, push it into the corner, and again I've made the game unwinnable. But this time I'm just going to exit the application with the game in an unwinnable state. I'm now going to press the play button on the toolbar, and notice the level begins in the unwinnable state because that was the last state of the level. Well, you might think that's no problem. I'm going to press the R key on the keyboard, and again the level begins, but because I press the R key and it loads the level again, every time it loads the level it detects that there's a game to restore, and it just so happens that the restore game we want to put back is always in an unwinnable state. So every time we restart the level, every time the level is reloaded, it continually brings back the save state, and we know the save state is an unwinnable state. So effectively what we want to do is say that every time we manually restart the level, we don't want to use this restore game data. We actually just want to use the default and initial state of the level. So in the next video we're going to get started at correcting this bug. Now to solve this bug, we need to realize that the game needs to be restored on one occasion and one occasion only. The only time we want to restore the game from the XML file is the very first time the game begins. On every other occasion when the player presses the R key on the keyboard and the level is reloaded, we want to reload the level back to its initial state and not the state in the save game data. To accomplish this and to solve this bug, I've created a new class called Level Counter, and I'm here in the very first scene, which is scene 00, and I've added a new game object called Level Counter, and I've assigned it here, you can see, the Level Counter component. And if I bring up MonoDevelop, you can see here we've got the Level Counter.c# script, and it's a special type of component. In the start function, you will see that I've called upon the don't destroy on load function, passing it the game object. And what this effectively does is it says never destroy this object. So what does that mean? Let's just minimize this here. It means that when the level changes from level 00 to level 01, this level counter object will move with it. It will persist throughout all the levels. And so every single level can keep track of whether the game has started and whether we've loaded a game previously. And the level load counter will increment to 1. Let's take a look at this. I'm going to switch over here to the Game Manager class and scroll down to the start function. So we've got the start function here. We check with the player preferences class if the level counter object, if the level load times is 0 or less, then this is the very first time that the player has started the game, in which case we do want to resort to the save game state. But once that has been loaded, the level counter is incremented, and we know then that the game has been restored at least once, and that we never want to restore it again, unless of course the player terminates the game and starts it again. So this will help fix our problem. So let's just take a look at this in action. I'm going to press play on the toolbar, and we begin here in the first level. So I'm just going to walk around and push a box onto its destination here and complete this level. And in fact, when I complete this level, what you'll notice here in the hierarchy panel is that the level counter object will move with us into the next level. Level 01, the second level, doesn't actually have a level counter object at all. It doesn't need one, because this first level has one and it will be taken with the game. So let's just push this box onto its destination. And we'll move over to this box here. Push that onto the destination, level complete. And now we move to the next level, but notice now we've taken the level counter object with us. So the level counter object is now with us. So here we've got our level. I'm just going to exit now, and when we press play on the toolbar, we will resume playback back at this second level here. Now what I'm going to do is I'm going to push this box into the unwinnable state that we've seen before, and I'm going to exit the level. Now I'm going to press play to restore the game. Notice that we restore back to the unwinnable state because we've restarted the game. But if I check the level counter, you'll see the level load times is now 1. It's not 0, which is where it begins. So this time, if I press the R key on the keyboard, it will restore the level to its initial state. You can see that here. I press the R key again, and notice that every time we restart, the level load times is incrementing. It's going up by 1. So now we're always resorting to the initial state and not the save game state. Of course, if I go back to here and push that back into the corner, exit the game, press play again, we begin in that unwinnable state, but I can easily fix that now. I press R on the keyboard and it restores back to that initial state. So that is how we can solve this kind of unwinnable game state bug using a level counter object. Well, congratulations, you've now reached the end of this course, and I've had a great time coding this box pushing game. Our game has explored many Unity features including level design, light mapping, light probes, skeletal animation, inverse kinematics, particle systems, chase view cameras, and not forgetting load and save game functionality. Right now, spend some time giving your game a solid test and, well, why not try adding even more levels? There are really so many level configurations possible with these assets, you can end up making a huge game. So I hope you've enjoyed this course and found it useful. This has been 3D Motive, and I'm Alan Thorne signing off. Take care and happy game development.